Welcome students. So we are discussing about maximum and minimum at a certain open interval. So today we will discuss the maximum and minimum value for the function in the closed interval. Is there any difference between the maximum value in an open interval or in a closed interval? So let's check. Take a function y is equal to x plus sine 2x. Now if I draw this tangent at this point here, 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 and here. Now look, this is parallel to the x-axis, and we are considering this interval 0 to 2 pi. Okay, so let's first find this points where the function is maximum or minimum. Okay, so for that you need to check the first derivative. So what is the first derivative? Is 1 plus 2 cos 2x. Now if this is the first derivative, the next condition is if the first derivative is 0 at a certain point, so that point, at that point function may has the maximum or minimum value. So if this y dash is 0, that means cos 2x is minus half. So put the general value for cos 2x is equal to minus half. That means 2x is given by 2n pi plus minus 2 pi by 3. And n belongs to the set of integers. Now, what is x? X is n pi plus minus pi by 3. Now, put n is equal to 0. If n is equal to 0, we will find that x is equal to pi by 3. Now for x, n is equal to 1. X is equal to pi plus pi by 3 and pi minus pi by 3. That is 2 pi by 3 and 4 pi by 3. Put n is equal to 2. So 2 pi plus minus pi by 3. 2 pi plus 3, that means in this region. So we will not consider 2 pi plus 3. We will consider only 2 pi minus pi by 3. That means 5 pi by 3. So this is 4 points given by pi by 3, 2 pi by 3, 4 pi by 3 and 5 pi by 3 in this region 0 to 2 pi. Now let's take the values, functional value at that point. So for x is equal to pi by 3, put pi by 3 into this equation, y is equal to x plus sine 2x. Put x is equal to pi by 3, that means pi by 3 plus sine to pi by 3, and put the value of sine to pi by 3, that is root 3 upon 2. So pi by 3 plus root 3 by 2. Next put 2 pi by 3 into the function, that is x equals to 2 pi by 3. So put the value x is equal to 2 pi by 3 and sine of 2 into 2 pi by 3, that is 4 pi by 3. So this will be 2 pi by 3 remain same, and the sine of 4 pi by 3 is minus root 3 upon 2. Let's check the functional value at 4 pi by 3. So put 4 pi by 3 and sine of 2 into 4 pi by 3, that is 8 pi by 3. So this means this is root 3 upon 2. Next check this functional value at x equals to 5 pi by 3. So if we put 5 pi by 3, the functional value will be 5 pi by 3 minus root 3 upon 2. So in this region, if we consider the open interval, so this is the point of maxima, this is the point of minima, this is again the point of maxima, this is again the point of minimum. Now if we consider the closed interval, what do you mean by closed interval? That means the first point and the last point, that is 0 and 2 pi, we will consider in this interval. And if it is open interval, we will not consider the 0 and 2 pi. But if it is closed interval, we will consider 0 and 2 pi. So let's check the value of the function at 0 and 2 pi. For x equals to 0, the functional value is 0. And for x equals to 2 pi, the functional value is 2 pi. That means among all these values, check 0 is the lowest value and 2 pi is the greatest value in this closed region. Okay, so that time we will call this f of 0 is 0 is equal to the absolute minimum value and this 2 pi is absolute maximum value. That means we will find the absolute minimum value here and absolute maximum value here. So this is the concept of defining maximum or minimum value in a closed interval. So for that one, we just need to check first derivative and then find this first derivative is 0, then find the critical point, and we need to check the functional value, that is f of c at this critical point also, and the closed interval, first point of this closed interval and the end point of this closed interval, that is f by fb. If we consider the interval is a comma b, closed interval. So this is our working rule for finding the maximum value, absolute maximum value and absolute minimum value. Now let's check the definition. Absolute maximum value. Among all the maximum value in a particular region, the highest value in this maximum value is known as absolute maximum value. Here is the definition. You can check. So in an interval, there are many maximum values. There are more than one maximum value can exist, but the absolute maximum value, just only one absolute maximum value can exist at the interval. So remember the difference between these two things, that is absolute maxima and maxima. Maxima means if we can find any changes in the nature, that is, it is changing, the curve is changing from increasing to decreasing, decreasing to increasing, and if dash x is 0 at that point, that time we can find the maximum or minimum value at that point. But for the absolute maxima, this is just only one absolute maxima can exist in a certain interval. But in a certain interval, there are more than one maximum value can exist. So remember the difference between absolute maxima and local maxima or maximum value. Now, what is absolute minimum value? Now, absolute minimum value, same, that is how we are defining this absolute maximum, we will define the same way the absolute minimum. Among the all minimum values in a certain interval, which one is the lowest minimum value? We will call this is absolute minimum. And similar manner, we can say there are more than one local minima can exist, but the ultimate absolute minimum value, just only one absolute minimum value can exist in a certain interval. So I think the concept is clear for maximum value or local maximum value, local minimum value, and absolute maximum value or absolute minimum value. Sometimes called the absolute maximum or minimum value as global maxima or global minima. So let's take some examples. Find the absolute maxima and absolute minimum value for the function fx is equal to x cube. We know fx is equal to x cube all over R, it is increasing function. It's an increasing function, it's always increasing. Whatever value we will take, it is increasing. Now, if you restrict its domain from -2 to +2, let's check the nature of this graph into this closed interval -2 to +2. So for that, our first work is to find f dash x, and then we need to find the critical point, that is f dash x is 0, then find this x is equal to c, critical point. Now, after finding this critical point, find the functional value at this c and this first point of this closed interval, that is -2, and f of 2, that is the end point. So firstly, we need to find f dash x. So what is f dash x? Differentiating this function with respect to x, you will find f dash x, that is 3x squared. And now f dash x is 0. For existing maximum or minimum value, definitely first derivative will be 0. So first derivative is 0, that means it will imply that x is also 0. Now if x is 0, so 0 is the critical point. So let's check the functional value at that point, that is the critical point. So put x is equal to 0 in the function, fx is equal to x cube, the value will be 0. Put x is equal to -2, that will be -8. put x is equal to 2. That will be 8. Now, in this, among these three values, which one is the maximum? Definitely 8. Which one is the lowest minimum value? Is minus 8. So this is your absolute maximum value and absolute minimum value. So here is the answer. The absolute maximum value is 8 at x equals to 2 and absolute minimum value is minus 8 at x equals to minus 2. In this closed interval, minus 2 to 2. Every time when you are defining or explaining maximum value, minimum value, absolute maxima, absolute minima, always just study the interval. Is it open interval given, or is it a closed interval given, or all over the R you need to find, that is all over the real set, you need to find the maximum or minimum value for the function. Just first check this interval. What is given? Is it open, closed, or total set of real number? What the interval is given, and then study the function and find this second derivative, first derivative, and then find the critical point. So another example, find the absolute maxima and absolute minimum value for the function fx is equal to sin x plus cos x, where x belongs to 0 to pi. So here the function is defining in this first and the second interval, second coordinate from 0 to pi. So what is the working rule for finding absolute maximum value, absolute minimum value? First you need to find this derivative, first derivative, then take the first derivative is 0, and if it is 0 then it will imply that x is equal to a critical point. Then find the functional value at that point also, and find the functional value at the starting point of this interval and at the end point of this interval. So firstly, find the first derivative. That means it is fx is equal to sin x plus cos x. So find the derivative, that is f dash x is cos x minus sin x. Now if this f dash x is 0, so simplify it, you will find, since sin x equals to tan x and then sin x equals to cos x, then tan x will be 1. Now you don't need to apply the general value for finding the value of x for tan x equals to 1, since in this first and second interval, this only positive value I can find in this first interval, that is at pi by 4. In the second interval, tan is negative. So we don't need to use this general value for tan x equals to 1. Just write down the principal value, that is pi by 4. Since the region is first and the second coordinate, that's why. If it is given from first to fourth coordinate, that time we need to check the general value. Okay, it's clear. Now check for x is equal to pi by 4, the functional value is given by √2, and at x equals to 0, the functional value is 1. At x equals to pi, the functional value is minus 1. So which one is the lowest value? Minus 1. Which one is the highest value? 1. So the absolute maximum value is 1 at x equals to 0, and the absolute minimum value is minus 1 at x equals to pi. In this interval, closed interval 0 to pi. So this is the way to find absolute maximum value and absolute minimum value for a function, or you can say the maximum or minimum value for a function is defining in a closed interval. For both the cases, you need to find the maximum, absolute maximum, absolute minimum value. Now, if any closed interval is given, a comma b, then the function at least one time it have this absolute maximum value occur in this interval at least one time, and absolute minimum value will occur at least once in this, at least once absolute minimum value will occur in this closed interval. This is a Parif theorem. So now let's check this one. Prove that the function do not have the maximum or minimum value. The functions are given e to the power x and log x. So check the graph of e to the power x. You all know that e to the power x is always increasing from this side. So it was moving this side. Now, we have to show it mathematically that it does not have any maximum value or minimum value. So for that, the function is e to the power x, y is equal to e to the power x. Now if we find the derivative, this is also e to the power x, and we all know that e to the power x is a non-zero quantity for all x into the set of real number. For every x in the set of real number, you can't find this e to the power x is 0. The value of e to the power x is every time non-zero. So we can't find any f dash c is equal to 0 for x equals to c. This is not happening. So from this one we can say there is no maximum value, no minimum, neither maximum value or minimum value. So similarly you can check this log x. Firstly check its graph. Look like this one. It's moving like that. Now if we differentiate the function y is equal to log x. Differentiation of log x is given by 1 upon x. Now 1 upon x is always non-zero quantity for x belongs to R. It is always non-zero quantity, so we can't find any c such that f dash c is 0 for x is equal to any c. We can't find this condition. So we can't establish this condition, so we can't find any critical point or stationary point. So we can say the function does not have any maximum value or any minimum value. So solve the problems maximum and minimum. We already complete this chapter. So solve more and more problems from this chapter, maximum and minimum, absolute maxima, absolute minima. Some geometrical concept, that is a case of cylinder, that we already learned in our previous class. There's some special problems are there, and definitely how to find this point of inflection, critical points, what is the definition of the critical point, how to identify the point as critical point or not, point of inflection or not, or a stationary point. So we already explained these things, and we already discussed some examples also about it. So practice it more and more, and you can solve the problems from any book you can choose. SND, R.D. Sharma, I.S. Agarwal, there are so many books are there. You can choose any book and find the solution and solve some problems. But solve the problems by yourself. First try to solve, break it into step by step and try to solve it. If you can't, then you go for the solution or go for the hint first, and then again try, then go for the solution. But first try the problems, solve the problems by yourself, which is very, very important to understand or to learn mathematics, which is very, very important that you should try to solve the problems by yourself, by knowing the theory, by knowing by your concept, which is very, very important. So practice it. So if any problem or any doubt is there, you're free to ask. Thank you.